Hi guys. Okay, let's look at balancing redox reactions using the half cell method. So there are certain steps to it, and the first step is always to assign the oxidation numbers to each atom. Next is we're going to split our reaction into two parts. One is going to be the oxidized cell and the other is going to be a reduced cell. Okay. Next, we are going to balance all other atoms except the hydrogen and oxygen. Next, we are going to balance oxygen by adding water. Next, balancing hydrogen by adding hydrogen ions. And in case our reaction is happening in the basic medium, we are going to introduce OH ions because we want to balance the hydrogen ions with that, but that's going to create water. So we are going to cancel the water molecules on both the sides, okay? Next, we are going to be balancing the charges by adding electrons to the oxidation side on the right hand side of the oxidation and on the left hand side of the reduction. Then we are going to make the number of electrons equal by multiplying one or both half reactions with the whole numbers. Okay, then we're going to add both the half cells, then we're going to cancel the electrons and other species across, and then we're going to check the balancing with respect to mass and charge. So here we are given this equation, iron in +2 state reacting with permanganate anion, giving you iron +3 and manganese with +2 charge. So this is happening in the aqueous medium, and so now we are going to first identify the oxidation numbers. Now oxidation numbers for the most part, as we said, are equal to the charges. So here is your iron in a +2 oxidation state. Here is your iron, the oxidation number is +3. Then comes your manganese here. The oxidation number is +2. Let us say we do not know the oxidation number of manganese. In this case, let it be X and we can find it. But oxygen we always know is going to be -2. So when you multiply, because there are 4 oxygens, so -2 times 4 and the whole of it added comes out to be -1. But let's find the value of X. So X, 4 times 2 is 8. So -8 is equal to -1. So X is equal to 8 plus 1, 8 minus 1, and that is equal to +7, or let's just do it properly, -1 plus 8, and that is going to equal to +7. Okay, so we clearly see that manganese right here is going from +7 to the -2 state. So iron, or let's put it here, iron is going from +2 to +3 state, and that's why iron has gotten oxidized, and we put it in a separate cell. So this is the cell for oxidation. So this is the oxidation cell. Okay, this is the oxidation cell. Next is look at a reduction cell here. Reduction cell is of this permanganate anion, which is MnO4 1 negative, and that is giving you Mn +2. Okay, now let's find the oxidation numbers of each. So we already found the oxidation numbers, but first we're going to balance now the non-hydrogen. So we see that iron and iron on one side, so these are balanced, and then non-oxygen also. Now next is, so this was 1, I'm going to just put this as 1 now. This is the next step is 2. You're going to balance the oxygen. So we have manganese, permanganate here, MnO4 1 negative, and this is giving you Mn +2, and you balance the oxygen by adding water. Okay, and how much water are you going to add? There are 4 oxygens on the left hand side, so you're going to put 4 here. Okay, so that 4 water molecules are actually we are looking at the oxygen first. So here is the oxygen, oxygen and oxygen. So 4 oxygens are balanced. Now we see that there are 8 hydrogens. So how are we going to balance the 8 hydrogens? We are going to bring in the hydrogen ions, and those hydrogen ions are going to be here. Bring in the hydrogen ions. Sorry. So 8 hydrogen ions, because 4 times 2 is 8. So 8 hydrogen ions and 8 hydrogens on the other side, plus MnO4, 1 negative, is giving you Mn plus 2 plus 4H2O. All right. So far we have balanced the hydrogens, 8 on both the sides. Okay, we balance the oxygen, which is 4 on both the sides. Okay, next is you're going to balance with respect to the charges. Now let's count the charges. Here they are going to, the way I do it is, here you're going to have 2 plus charges, and here you have plus 3 charges. Here you have 8 charges, or plus 1. Okay, and then you have 1 negative charge coming from, you have to add these, 1 negative charge that is coming from the MnO4. Okay, and then here you have 2 plus charges coming from manganese, and then this one is going to be 0. Okay, so here you're going to get 8 minus 1, that is plus 7 charges, and here you have only plus 2 charge. Okay, so how are you going to balance these? So you will have to make them, and similarly iron also, if you look at it, iron is plus 1 plus 2 charge on one side and minus 3 on the other side. So we will have to reduce this. How do we reduce this? How do we balance this now? Let's look at the, I'm going to use a different color for it. Let's look at this. Okay, so for the oxidation cells, as we talked about here, right-hand side of the oxidation cell, you add electrons to balance it. So if you look at it in the oxidation cell, this one is plus 2 and this one is plus 3. So how do you make this equal? So plus 3 plus minus 1 charge, and as minus 1 charge is that 1 electron. Okay, so that is that 1 electron, the charge from 1 electron. So I'm going to just put it a little bit more cleanly here. This is plus 2 is equal to plus 3, okay, plus 1 electron. Okay, so that makes it plus 2 equals plus 2. So this is how the charges got balanced. Now let's look at it here. So here you have on the reduction side, remember the rule is charges by adding electrons on the left hand side of the reduction cell. So clearly here you will have, so you will have to make it 2 now. So this is 2, you have to make it 2. How can you make it 2? So here is your plus 7 and you will have to add 5 electrons, okay, to make it plus 7. So in other words, minus 5 plus 7 is equal to 2. Or in other words, 7 minus 5 is equal to 2. So 2 here and 2 here. This is how you balance the positive and the negative charges. All right, next is you're going to make the number of electrons the same. The only thing is, now pay attention. You had added 5 electrons here. So 5 electrons were added in this case, and only 1 electron was added here. Only 1 electron was added here. So we need to balance the electrons now. So let's write this equation again with what we have so far. And that is, we have, we're going to actually, we can combine these two. So we can combine these two now. So 3, 4. So here we have iron, okay, with its plus 2 charge, and that's giving you iron plus 3 charge, and you have 1 electron here. Okay, this 1 electron that was added. Okay, that's one story. Next is you're going to look at what you did here. You added 1 electron, sorry, you added 5 electrons here. So you're going to write down here 5 electrons plus 8 hydrogens, okay, and these are all in aqueous, plus the MnO4, 1 negative, is giving you Mn plus 2 plus 4 H2O. Okay, so if you look at it, this is what we have. 8 hydrogens, MnO4, Mn plus 2, and 4H2O. And then 5 electrons from here, the ones that were added to balance the charges. And here we have 1 electron that was added to balance the charges. So it's very clear that in this case that electrons are not balanced. So how do we balance the electrons? In this case, you are now going to add one more electron. You're going to add 5 here, okay? 5 times. So basically you multiply the whole thing by 5. Multiply by 5. Multiply by 5. So when that happens, this becomes 5. This becomes 5. And these also become 5. Okay, so 5 electrons, and this is 5, and this is the 5 electrons. Okay, multiply by 5. Let me write it down. Okay, next is you are going to cancel out what is common. So as you can see that we will see that the 1 minute, let me get this color. Okay, so we see 5 electrons here and 5 electrons here cancel out. Okay, what else can cancel out? Nothing else. So we can just going to bring back now iron 5 plus 2 plus 8 hydrogen ions plus MnO4 1 negative. Okay, so just adding all this, and then comes 5 Fe plus 3 plus Mn excuse me, plus 2, and then plus 4 H2O. Okay, so that is your balanced equation. Now step 5 is to check for the masses and the charges. Okay, so how do we do this? We're going to look at the irons. So there are 5 irons on this side, on the reactant side, and on the product side. Let's look at the product side. How many irons do we have? Product side is also 5 iron. Then we have 8 hydrogens on the reactant side, and we are having 8 hydrogens on the product side. Excuse me. Then we have 1 manganese on the reactant side, and we have 1 manganese on the product side. We have 4 oxygens on the reactant side, and as you can see, we have 4 oxygens on the product side. Now let's look at the charges. Now the charges are 5 times 2, 10, 8, so 10 plus 8, yeah. So let's just do this, charges. Bring all the charges on one side. So 5 times plus 2 charge plus 8 times plus 1 charge plus then you have 1 of permanganate times minus 1 charge. So this whole thing adds up to be 17. Okay, this whole thing. And on the other side, let's look at this. For iron, 5 times 3 is 15. So 5 times plus 3 plus 1 times plus 2 plus 0. Okay, so here you have 15 plus 2, and that is equal to 17. And here you have 5 2s are 10 plus 8, 18, and then that would be minus 1. So that's 18 minus 1. Or better if I write it more, a little bit more clear, that is 10 plus 8 minus 1. And that is equal to positive 17. And that the other one is also positive 17. So plus 17, the charges are also balanced. So this is how you do the balancing of the redox reactions by the half cell method. And this was an example where the reaction was in the acidic medium. So I hope that was easy, and thank you for watching.